Hi, my name is HilmyRukmana, and this is Lab 1 of Physics 2212, charge tapes. So the ideas of this experiment, we're learning about charges, which are properties of matter, designing experiments, using household objects, making estimates and simplifying assumptions, and the amount of excess charge on everyday objects we are calculating. The purpose of this experiment is to determine approximately how much excess charge is on one piece of charged clear tape. Materials needed are a roll of clear tape, a ruler, flat surface, and 2 thick books or other stackable objects. Now I'm going to go through the procedure. So we want to prepare the U-tape by peeling a piece of tape folded over at one end and labeled U off a piece of base tape. Then rubbing U-tape against the plastic pen, we're going to basically grab the pen's negative charge. To test for electronegativity, we're going to place the tape at the end of a surface and move our hand near it, and if it moves, we did a good job. And then we need to repeat this for another piece of tape, label one tape A and the other tape B. And after placing tape B across 2 books, we're going to lift tape A below tape B until there's movement and measure that distance the instant they interact. So I predicted that both pieces of tape would share the same charge, and therefore they would repel each other. And what I observed is exactly what I predicted, and against a neutral object, in fact, they attracted because the neutral object is more oppositely charged relative to the charge of an identically charged piece of tape. Result, the tape had a charge of negative 2.87 times 10 to the negative 8 coulombs with an excess of electrons on the tape. If the U-tape was positively charged, how should it interact with the plastic pen? If the pen is negatively charged, the tape should be attracted. If the pen is positively charged, the tape should be repelled. And literally vice versa. How should a neutral U-tape interact with the charged plastic pen? The two would attract weaker than if they were strongly charged objects. Now rubbing a clear plastic pen on cloth or hair, it forces the pen to be negatively charged itself, and then rubbing it against the U-tape makes the U-tape positively charged, and then since they attract one another. Balancing gravitational and electrical forces. Since the momentum of B is not changing, the net Y component is 0. Tape A exerts a force upward on tape B, while the Earth's gravitational force exerts a force downward on tape B. And here's the FBD of that. Measurements and data. The length of my piece was 0.204 meters approximately. Mass 2.04 times 10 to the negative 4 kilograms. The distance that I measured them to react or interact, I guess, is 0.03 meters. Magnitude of the gravitational force was calculated to be 1.99 e to the 1.99 times 10 to the negative 3 newtons. Likewise for the electric force on the floating tape. And then the charge on the floating tape is 2.92 times 10 to the negative 8 coulombs. Here are my calculations. Like I said, the distance 0.04 meters. More calculations. And then here, when I was computing the final ratio between the number of electrons and number of atoms, I could assume that there's no air resistance. Both tapes have the same charge, and we could treat the tape charges as a single point charge located at the center. Here's my glow script. There's the link, which is also going to be in the bio. I'm going to declare my constants and E field, which is like the electric field. Here's some calculations. Things to focus on here are I'm basically declaring where my top tape is and where the bottom tape is and scaling them. Over here, I'm basically creating a loop so that I can calculate the electric field / electric force at each point at the top tape due to the electric field of the bottom tape, and vice versa. And I'm also creating arrows to signify the forces. So yeah. And then here's the output / visualization. So bottom arrow is force of gravity, top white arrow is electric force, and then the green arrows are those magnitude arrows that I was explaining earlier, where I use a for loop to visualize the electric force at each point on the top tape. Reflection. So calculating the magnitude of the charge on one piece of tape computed as a single point charge is 4.7 times 10 to the negative 3 newtons. Likewise, for a line of charges, 1.43 times 10 to the negative 3 newtons. And what if the electrons were negatively charged? And the rest of the question, so since they still share the same charge and sign, they would still repel each other. And then at a concentrated, and then y, compare the estimated value of the charge, that's the question. And then at a concentrated single point, the field is larger, the collective electric field is further than a centralized one, alongside having repelling effects because of the opposing directions. This is basically explaining the differences between treating something as a single point versus a collective electric field. And that's it. Thank you.